Okay, students, we're going to see about solving the quadratic by the quadratic formula. We just did it last time by completing the square. We've done it by factoring. We've done it by graphing. Now we have a quadratic formula. Some of you have it memorized. If not, you need to memorize this major formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so work on saying that correctly. Notice there's two answers here. It's negative b plus that radical over 2a, negative b minus that radical over 2a. Because remember, when we're solving a quadratic, we always have two answers. Okay, the degree of the polynomial tells you how many answers there are. Okay, first thing we're going to do with quadratic, whether we're doing it by completing the square or, well, you don't have to complete the square, but most time you are putting it in standard form. So notice this is rewrite the equation as that, which is standard form, and subtracted the 14 across. So the first step we've already talked about is set equal to 0. This is even in factoring. We solve all quadratics. First step, set equal to 0. Step 2, factor out the GCF. Greatest common factor. Okay. Step 3, factor what's left if possible. That's if you're doing by factoring. We're not going to do that. We're going to use a quadratic formula. Factor what's left. I'm just reviewing this because you need to have it memorized. So I'll write down all 4 of these. And lastly, set each factor equal to 0. I might make this a test question. Set each factor equal to 0 and solve. Remember, that's called the zero product property, when you set each factor equal to 0 and solve. Okay, so we're going to still do the first 2 steps, because by factoring out the GCF, then instead of factoring what's left, if possible, we would use a quadratic formula here. That'd be the difference. Okay, quadratic formula. Now, if you don't take out the GCF, you can still use the quadratic formula. You could go from step 1 to step 3. The difference is you're going to deal with a lot larger numbers. So if you're doing it by hand and you want to work on your mental math skills and stuff like that, you want to take out the GCF so you deal with smaller numbers. If you have a calculator, it really doesn't matter because you're putting everything in the calculator. But as you know with me, I prefer to use my brain, okay? So it doesn't go to waste. If you don't use it, you'll lose it. Don't forget that phrase. Okay, so you want to keep using your brain. It's like you want to read, keep reading books. Okay, so you work on your reading skills. That's something I didn't develop till college. I only read what I had to, for the most part, throughout high school. The rest of the time I was playing sports, watching sports on TV. All right, other shows. Anyway, so and it's talking about using the discriminant. The discriminant, just so you know, the discriminant is what you see underneath the quadratic, the b squared minus 4ac. That's called the discriminant. Discriminant. That's spelled right there. Okay, so that piece is right there. I'll just erase that so I couldn't fit it in there. Okay, b squared minus 4ac is the discriminant. Now, what does that tell you? It tells you what type of solutions you're going to have. And it's going to tell you that a lot of teachers don't tell you. It's going to tell you whether it factors or not. So first off, write down what you have here. Pause the video, write down. I'm going to erase all this. And then we'll talk about the discriminant before we actually get into the quadratic formula. Okay. So discriminant. If b squared minus 4ac equals 0, one real solution. Okay, if b squared minus 4ac is greater than 0, 2 real solutions. You should be writing this down, and you got to memorize this. I'll ask in class for extra credit. If b squared minus 4ac is less than 0, to imaginary solutions. What's imaginary again? When you have a negative underneath the radical. Because doesn't this mean it's, remember, this is what's underneath the radical. That says it's less than 0. That means it's a negative. That's an imaginary number. Okay, now that's typically what you see in books. That's typically all your math teachers will tell you. But another key to know from the discriminant, which some people, if they can't factor, they always revert to quadratic formula pretty much, or graphing calculator if they're allowed that. Okay, but if you have to show work, it can be quadratic formula. So they have to become really good at quadratic formula if they can't factor. Well, if you're good at factoring and you want to see if you can factor that, now I could just do that in my head. It's such small numbers real quick. Okay, but say it wasn't something easy for you to figure out. I could do b squared minus 4ac. So in this case, b squared 25 minus 4ac. So I have 25, a negative times negative is plus, and 4 times 14 is 56. I'm working on mental math skills, and that gives me 81. Notice 81 is a perfect square. The square root of 81 is 9. That tells you, if it comes out to be a perfect square right here, that tells you this will factor, guaranteed. Okay? Now that's assuming you did your b squared minus 4ac right to come up with the right answer of 81. Okay? But if you did it right and it's a perfect square, that will factor. Okay, so that's the huge benefit of checking out the discriminant as far as I'm concerned. Okay, now graphically, okay, let's talk about what this does graphically. If I have one real solution, this one right here, I'm going to draw a quadratic. That means it's going to hit the x-axis and bounce back up, or hit the x-axis and bounce right back down. You get the same answer twice. That's what the green one does. If it is the blue one here, greater than 0, so you have two real solutions, then it's going to cross the x-axis twice in two different spots, either up and down, vertical, up and down, opening up, or opening down. Lastly, if it's less than 0, so you get a negative answer underneath radical, it's not going to cross the x-axis at all. So it's going to be, the graph will be completely above the x-axis or completely below the x-axis. It will not cross the x-axis. So that's another benefit of doing the discriminant, is that should tell you what kind of graph. Before I've even graphed it, if I'm having to graph it by hand, not able to use my graphing calculator, okay, got to do it by hand, which is what I would have you do in class and on your test, because we know the calculator is smart. That doesn't make you smart. We want you to become smart and use your brain, okay? And I want to see that you keep up with your basic math skills too, okay? So by the way, since we know this factors, you should be able to quickly do that one of x minus 7 and x plus 2. So my two answers are 7 or negative 2. So that's where it crossed the x-axis, 7 and negative 2, which we get right down here. Okay, so that's doing it from factoring. Okay, and so that would be another way, even if you're required to do it with quadratic formula by checking the discriminant. If that came out to be a perfect square, that'll let me know I could factor it. And if you're good at factoring, you could factor it and see if you got the same answers. Again, this is assuming you can't use a graphing calculator, because you could do it all on the graphing calculator and just pop out the answers for you. All right, so plug in the quadratic formula now. After I put in standard form, which means set equal to 0, identify my A. A is 1, B is negative 5, and C is negative 14. Double check that you've written down those numbers correctly, because if you have one wrong sign or number, it blows your whole answer. Okay? And again, if that's important, if you didn't have a graphing calculator, so you could check your answers. Okay? So now we just plug it into this formula and get our two answers. So negative b, negative of negative 5 is positive 5, plus or minus b squared is 25 minus that 4 times a times c, which I've already done right here. It gives me 81 underneath the radical, which is what they have right there. So I have 5 plus or minus 9 all over 2. 5 plus 9 is 14 divided by 2 is my 7, and 5 minus 9 is negative 4 divided by 2 is negative 2. And there's your two answers. Okay, so that's how you plug in the quadratic formula. A lot of people blow it. Don't forget. Well, see, now you can get messed up because now you know imaginary numbers, so you could come up with complex or imaginary solutions. Okay, or complex solutions. Okay. Before this, you could only end up having a positive number underneath the radical because you hadn't been introduced to imaginary numbers. Well, now you can. Well, that now adds a possibility of more error. Okay, because before you should have known that you couldn't have a negative underneath the radical. Well, now you can. So you need to really pay attention to your signs that you're plugging in there. You better be checking if you have two negatives there, negative times negative is a positive, and you change it to a positive. That's a common wrong error that students make. Okay, they would do 25 minus the 56. Okay, and write down negative 31 and say, oh yeah, I can do that because I have I for negative 31 and I have I root 31. Okay, but it's because they blew the negative times the negative as a positive, and then it would be an 81 underneath. Okay, so make sure you're checking for that. All right, so that's what you're doing with all those. Okay, next page. Okay, this is actually better than I've seen in most books right here. Because remember, this is what I talked about here, and a perfect square. Okay, now it tells you there's two rational roots, but the key that you want to add on to this is means this means it factors. Okay, if it's anything else, if it's not a perfect square, it's not going to factor. Okay, if it's 0, it would factor as well. Factors. Okay, and complex is not going to factor. I pause because it technically could factor if it was a perfect square, but we did not teach you here. I might throw it on if I had extra time. In an honors class, you can factor complex numbers, but it's not usually taught. So when I say it doesn't factor, it technically does if it's also a perfect square like number 1. Okay, if you want to learn how to do that on the side, you can come to EL, for example, or after school. If I'm available, and I'll teach you that. Okay. All right. Find the value of the discriminant for each equation. Then describe the number and type of roots for the equation. So when it says the number and type of roots, that's using this right here. This is the number and the type of roots. They're wanting these answers, one of these 4 answers. Okay, remember, rational number means it's a fraction. It can be written as a fraction. Irrational can't be written as a fraction. Okay, we've already written down that vocab in previous sections, but that's just a quick review. You need to know that anytime. All right, so complete exercise. Find the value of the discriminant. That's your b squared minus 4ac. Just fill it in, get whatever number it is. And then if it's positive, you know it's 2, and it's not a perfect square, 2 irrational roots. If it's a perfect square, it's 2 rational roots, which also means it factors. If it's 0, 1 real root. And they put rational root. Yes, 1 rational root. And if it's negative, it's 2 imaginary or complex roots. Okay. Or a complex number has an imaginary number within it, the I. Okay, so quadratic formula analysis. You can, such as 11, you could divide, if there's a GCF and all that, you could divide each one by 2. Okay, and again, that would then make it smaller numbers to plug into the quadratic formula. That's what I would do. Okay, anytime possible. Okay, looks like that's the only one that has that I'm seeing here. Yeah. Okay, that goes ahead and does that section.